Still on quadratic equations under algebraic process, we are going to learn how to derive quadratic formula and then use the quadratic formula to solve quadratic equations. Quadratic formula can be used to solve any kind of quadratic equation, whether it can be factorizable or not factorizable. Okay, so now we recall the general form of quadratic equation. To derive the formula, let's state out the general form of quadratic equation. Okay, the general form of quadratic equation is ax squared plus bx plus c equal to 0. Recall a being the coefficient of x squared, b being the coefficient of x, c the constant, and equal to 0. Now the first thing we are going to do, we are going to make use of completing the square method in deriving this formula. Recall the first thing we are going to do, we move the constant over. And in order to move the constant over to the right hand side, we subtract c. This is positive c. When we want to remove it, to subtract c from both sides. So this is what we have now. Okay, so c minus c is 0. So we have ax squared plus bx is equal to minus c. After subtracting c from both sides, we divide through by the coefficient of x squared. Coefficient of x squared is a. Okay, so now we have x squared plus b over ax plus, equal to minus c over a. Remember, we are using completing the square method. So in order to make the left hand side a perfect square, we are going to half the square of the coefficient of x. Half the square. Half first is b over a. We half it is b over 2a. That is half of it. That's 1 times b is b, 2 times a is 2a. Then you square it. The square of it is b square over, because the square of b is b, the square of 2 is 4, the square of a is a square. So we can make use of either this or this. We are still saying the same thing. After halving and squaring the coefficient of x, we add it to both sides. A squared plus b over ax plus b over 2a all squared is equal to minus c over a plus b square over 4a square. We factorize it. When we factorize it, we have x plus b over 2a. They are both carrying square, is equal to, let's interchange this so that I don't want minus to start the statement. I want positive to start the statement. So it's going to be b square over 4a square minus c over a. Now if you look at what I did here, I wrote this one like this, and I also wrote, is the same thing. My reason for writing this one this way, I want it to be properly expressed. Then this one, I want it to look like the square so that we'll be able to factorize. That is the reason why I left it the same way as this. Okay, so that's why we are able to factorize. We get the square of this. Now we want this square to go. In order to let that square go, remember what we do? We introduce our square root. Is equal to b square over 4a square minus c over a. Introduce square root. When you introduce square root, add your plus or minus. Introduce square root. square goes with square root, and we're left with x plus b over 2a is equal to plus or minus the root of b square. Let's first look for the LCM. LCM of 4a square and 4a, is 4a square. I don't want to be carrying so much number. I don't want it to be ambiguous. That's why I want to look for the LCM. 4a divided by 4a is 1. 1 times b square is b square. Still remain the same. Minus 4a divided by a is 4a. 4a square divided by a will cancel one of this a. We are left with 4a. 4a times c, that's 4ac. So now what we have here is x plus b over 2a is equal to plus or minus b square. We can find its root, but we can't find this root, so we leave the root the same way it is. B square minus 4ac. What is the root of 4a? The root of 4 alone is 2. The root of a square is what? A. So now what's the next thing we do? We move this one over to this side. So we have x is equal to, so that x will be standing on its own, plus b moving over becomes minus b over 2a plus or minus the root of b square minus 4ac all over 2a. I want it to have one common denominator, so we look for the LCM as well again. LCM of 2a and 2a is 2a. 2a divided by 2a is 1. 1 times b is minus b. Put your sign plus or minus. LCM of 2a divided by 2a is 1. 1 times everything. The numerator is the same thing as root b square minus 4ac. Therefore, this is your quadratic formula. Now let's use this quadratic formula to solve, to get the two possible values of x in an example as this. 5x squared plus 3x minus 3 is equal to 0. From the general form of quadratic equation, we say ax squared plus bx plus c is equal to 0. This is the coefficient of a here. Coefficient of s squared here is 5. Coefficient of b is 3. And then the constant is minus 3. So a is equal to 5. B is equal to 3. And our constant c is equal to minus 3. We insert our formula. X is equal to minus b plus or minus root of b squared minus 4ac all over 2a. So x is now equal to, our b is minus 3. Wherever you see b, we put our 3. Plus or minus root of b is 3 squared minus 4. What is our a? 5. And what is the c? Minus 3 all over 2 open bracket 5. So we say x is equal to minus 3 plus or minus the root of 3 squared is 9. 4 times 5 is 20. 20 times minus 3 is minus 60. Minus times plus is plus 60 all over 10. So x is equal to minus 3 plus or minus root of 69 over 10. So we can, this one is an irrational number, but then we'll get a decimal number. That means our x will now be equal to minus 3 plus or minus 8.31 when you punch your calculator, the root of 69 is 8.31306. So I approximated it to 1 to 2 decimal places, all over 10. So the two values of x is now x is equal to minus 3 plus 8.31 over 10, or minus 3 minus 8.31 over 10. So x will now be equal to 0.531 or minus 1.13. So it then means that we have gotten the two possible values of x to be 0.53 or minus 1.13.